Okay, today we are going to learn chapter 1, real numbers. Real numbers. Numbers. Real numbers. Now, in class 9 you learned rational numbers, and irrational numbers. Irrational numbers. Now, rational numbers, you learn rational numbers. A number R is called a rational number if it can be written in the form P by Q, where P and Q are integers and Q not equal to 0. And irrational numbers, a number S is called irrational if it cannot be written in the form P by Q, where P and Q are integers. Okay, so that definition I will write again. So these rational numbers and irrational numbers together, rational numbers and irrational numbers together form a group of numbers or a set collection of numbers called real numbers. That means real numbers, R for real numbers, include rational numbers small r plus small s. Small r for rational numbers, small s for irrational numbers. R is real number. So real number is a collection of rational numbers and irrational numbers. Now, rational numbers definition, a number R is called rational if it can be written or expressed in the form P by Q, where P and Q are integers and Q not equal 0. So a number R, small letter r, is called a rational number if it can be written or expressed in the form P by Q, where P and Q are integers and Q not equal to 0. So this is rational number definition. You learned it in class 9. Also, for irrational numbers, a number S is called irrational if it cannot be written or expressed in the form P by Q, where P and Q are integers and Q not equal 0. Just the opposite. If that number, particular number, can be written in the form P by Q, where P and Q are integers? If it can be, then it is rational. If it cannot be, if it cannot be written, then it is irrational number. Now these two sets of numbers, rational numbers and irrational numbers together. So what is real number? So the collection of all the rational numbers and the irrational numbers the collection of all the rational numbers and irrational numbers form the collection of a group of numbers called real numbers. Okay, so real numbers are denoted by capital R. Means when you see capital R is there, it is real number. So the collection of all the rational numbers and the irrational numbers together form the collection of a group of numbers called real numbers. So real numbers means total of rational numbers and irrational numbers. Rational numbers and irrational numbers together form a group of number, big group of number. This is called real numbers. Okay, this group is called real numbers. It is generally denoted by capital R. So small letter r is rational number, small letter s irrational numbers, capital letter R real number. So this is the idea about real number. Now rational numbers, irrational numbers, you should know which particular numbers are rational numbers. That also I tell you. In the group of rational numbers, you have natural numbers, whole numbers, all the integers. Okay, all the integers. Decimal numbers. Decimal means two types of decimal numbers: terminating decimal numbers and non-terminating repeating decimal numbers, and the fraction. These all constitute rational numbers. Then which are irrational numbers? Numbers such as square root 2 means square root of a non-perfect square. Square root of a non-perfect square. So rational numbers, some examples. Examples of rational numbers. Rational numbers. Okay. Say, let me start from -1, 0, 3. Okay. -1, 0, 3, say 2 by 5. Okay. -3 by 7, 1.7, etc. These are rational numbers. Because all these numbers, some are already in the form P by Q. Q should not be 0. Some may not be in the form P by Q, but we can express them in the form P by Q. Examples of irrational numbers. Irrational numbers. Square root 2, square root 3. 2 and 3 are non-perfect squares. Okay. Say 1.01, 001, 0001 and so on. Like this. These are irrational numbers which you cannot express in the form P by Q, where P and Q are integers and Q not equal to 0. So this is the idea of rational numbers and irrational numbers. Here I go again. Minus 1 is a negative integer, 0 is an integer, 3 is an integer, 3 is a natural number, 3 is a whole number, 0 is a whole number, 2 by 5 is a rational number, minus 3 by 7 is a rational number, 1.7 is a terminating decimal number. Okay, non-terminating repeating decimal numbers are also there. Okay, so all these numbers together, okay, are called real numbers. Okay, now we will go to a very important part of these real numbers, which is known as Euclid's division lemma. Euclid's division lemma. Now what is Euclid's division lemma? It is like this. Given positive integers a and b, means two positive integers a and b are given to us, okay, comma, there exist there exist unique integers q and r. I read again. Given positive integers a and b, there exist unique integers q and r satisfying this relation. What is the relation? A equals BQ plus R. BQ plus R. Now what is R? R is less than B but greater than equal to 0. Once again, this is the division lemma of Euclid. Given positive integers a and b, there exist unique integers q and r satisfying this relation. What is the relation? A equals bq plus r. A is here in simple language. A is dividend, b is divisor, q is quotient, r is remainder. Once again, A is dividend, B is divisor, Q is quotient, R is remainder, but we don't use those names. Here we express it in this form: A equals BQ plus R. R is remainder, R less than B, greater than equal to 0. This one I will explain a bit elaborately. Okay, so let me explain this R. You need to understand R, that is remainder, very nicely here. Okay. Suppose, let me take a number, a positive integer, say 37. Okay, 37. I have taken a positive integer 37. Now you see, 37 I divide first by 2. 2 1s are 2, 1 7, 2 8s are 16. 1, you see 1 less than b, this is b, less than b, less than 2, but 1, it is 1, it is greater than 0. Now 37 I divide by 3, 3 1s are 3, then 7, 3 2s are 6, here 1, here also remainder is 1, you can see 1 is less than 3, that means remainder is always less than the divisor. Now let me divide 37 by 4. Okay, so 4 9s are 36. Okay, here remainder, so 1 less than 4. Okay, let me divide 37 by 5. 5 7 are 35. Remainder is 2. Is it 2 less than 5? So what you see, let me take one more number. 37, let me divide by 6 or 7. Okay, 6 also will give you remainder 1, say 7. 7 also will give you remainder 2. Let me take 8 then. Okay, 8 if I divide it by 8. 4 8s are 32. Remainder 5, you see. 5 is less than 8. So, every case you have seen that the remainder is less than the divisor. Remainder can never be greater than divisor. It can be 0. It can be 0. Now, if I divide 37 by 37, it can be 0. It can be 0. Okay. So, from this one, the Euclid division lemma comes in this manner, that if A and B are two positive integers, such that any two positive integers A greater than B. If A greater than B, will divide A by B. Okay. Then since A greater than B will divide A by B, then Q will be the quotient. Okay, say BQ or whatever comes, and R will be the remainder. So A equals BQ into R. BQ plus R. B into Q plus R. This one comes. So this for any type of division. Now suppose if I divide, say 20 divided by 4. 4 5s are 20. Then it is 0. Remainder is 0. So 20 equals divisor is 4 into quotient is 5, remainder is 0. Now you see, in other cases you have seen the remainder came out when I took 37, remainder 1, 2, etc. were there. But here remainder is 0. Now when the remainder is 0, when R equal to 0, if R equal to 0, then this divisor 4, this 4 is the highest common factor of 4 and 20. 4 and 20. That means if A equal to BQ plus R and R equal to 0, then if R equal to 0, then B is the HCF of A and B. B is the HCF of A and B. Okay. So here, this is the lemma, and this lemma is used in proper steps. In proper steps, we call what is called Euclid division algorithm. Division algorithm. So here, these two definitions you should know. A lemma is a proven statement. What is a lemma? A lemma is a proven, P-R-O-V-E-N, proven statement. A lemma is a proven statement used for proving another statement. Used for proving another statement. So what is a lemma? A lemma is a proven statement. It is already proved, and we use it for proving another statement. This is called lemma. And the lemma that I have given you, A equal to BQ plus R, this is Euclid division lemma. Okay, Euclid division lemma. So this is the proven statement, means it happens. When we divide a number by another number, then the relation among all the numbers comes in this manner, that A equal to BQ plus R, where A is greater than B, and Q and R are two other unique integers. That means Q is quotient and R is remainder. Now what is an algorithm? Okay. An algorithm is a series of well-defined is a series of well-defined steps. Well-defined steps. Okay. A series of well-defined steps which gives a series of well-defined steps which gives a procedure okay, for solving a type of problem. Procedure for solving a type of problem. A type of problem means any type of problem. So this is algorithm. So an algorithm is a series of well-defined steps which gives a procedure. It is a procedure for solving a type of problem. So now when you find HCF of any given two numbers, there will be some steps. Those steps are together, we'll call them algorithm. And each step will contain the division lemma. So in this video, you are learning division lemma, what is algorithm, and real number definition basically. Okay. In the next video, I will show you how to find the HCF of any two given numbers.